How does AI learn? While current AI systems are quite far from the science fiction depictions of machines that can think and act like humans, AI researchers are working on ways to enable computers to perform increasingly complex tasks. In order to do so, computers need to be able to learn things similarly to how humans do. But how similar is the learning process between humans and computers? I'm Dr. Hiram Ring, a linguist working at the intersection of anthropology, psychology, and computers. This video is part of a series that I've started to help people make sense of AI and filter out some of the noise surrounding artificial intelligence in its current state. If you enjoy this content, please like, subscribe, share it, and do leave a comment if you have any questions, feedback, or suggestions. In a previous video, I suggested that what people currently describe as artificial intelligence is not particularly intelligent, at least not yet. And a better set of terms for the acronym AI is automated inference. But if our goal is to make machines intelligent, we need to solve or address multiple concerns that are part of our understanding of intelligence. One of those aspects is related to learning, which essentially is the ability to incorporate information that informs or affects a particular task or behavior in order to perform that task better. Now, in order to assess whether computers can do this, we need a way to measure it. So how do we measure learning? There are three major components to this measurement. We need to have a baseline performance of a learner, some process for training or teaching a particular task, and then a way to evaluate the learner's performance to see whether they exceed the baseline. Think, for example, of how you learn to spell words. As a learner, the baseline for me in second grade was my ability to spell based on words that I recognized from books. At the beginning of every week, my teacher would give us a list of words to study throughout the week, which was our training. And at the end of each week, we would have a spelling test, which evaluated our performance. We would repeat this process and incorporate feedback from the teacher, and hopefully by the end of the year, my scores were higher than at the outset. I don't quite remember. What modern AI systems do is advanced pattern recognition. They infer solutions from data to accomplish particular tasks. This inference is based on observations of solutions from similar data. The spelling test actually requires a good deal of skill. As a learner, I have to map noisy auditory input, the pronunciation of letters, to their graphical representation. And some of those mappings are rather arbitrary. A computer system that does speech-to-text transcription is doing something similar. There are various complex subtasks that it needs to manage in order to convert sound patterns to written text. As another example, nowadays many people can unlock their phones by simply looking at the screen. Facial recognition is made possible by a built-in camera that takes a series of pictures of your face and compares it to a database of pictures of other people to find the particular pixels that differentiates your face's image from others. Here we would say that the system starts at a simple baseline of being unable to recognize individual faces from the pixels in an image. Then it goes through various training steps and some testing to evaluate whether it can recognize particular faces. Through this process, the system is learning a set of patterns that correspond to different faces. But how do AI systems identify or learn these patterns? What is the actual mechanism? The answer to this is both simple and complex. The simplicity is that the basic principle involves memory and statistics. Typically, you start with some memory node or neuron, which represents a saved state. Then you run statistics on data and update that neuron with information. You then use that information to do more statistics, then update the neuron with the results, and repeat. That's the simple part. But a single neuron can't hold much information, and that's where the complexity comes in. The complexity is in the number of memory nodes or neurons that are used and the way they're organized or the architecture. As networks of neurons become more complex and connected in different ways, the neurons and bundles of neurons can specialize in different kinds of information within a given data set. This process is called machine learning, and these kinds of architectures are often called neural networks. The idea is that this process, which is often termed as Bayesian inference, using prior information stored in memory to draw conclusions, and then updating the information stored in memory in an iterative fashion mimics how humans learn. But the reality is that we don't actually understand very well how the human brain processes information in learning. There's quite a bit of research in this and various theories, but the actual process of learning is rather complex. The computational model works surprisingly well, however, and has allowed for automation of various tasks related to images, language, security, etc. There are a couple major differences that we do know about regarding how computers and humans learn. The first difference has to do with data sparsity. Statistics are the basis of how computers identify patterns, and this works best when you have lots of data. But humans seem to be able to learn just as well with very little data. We have the ability to make generalizations from few data points and then update those generalizations on the fly. The second difference has to do with using inference to generalize well to new contexts. Computers are very good at memorizing the data they're exposed to, but they often fail when presented with data that has marginal relation to anything in their training data. Humans, on the other hand, can relatively easily apply skills and principles from one context to another. So, how do computers learn? Mostly, computers learn from data, saving information in memory, and then using that information to make inferences toward a particular goal. The computer then evaluates those inferences, updates the memory, and repeats the process. Computers seem to learn best with lots of data and high-quality data, and there are always new architectures being proposed for neural networks. But these neural networks are really just models of learning that differ in many ways from how humans learn, and by better understanding these differences, we may be able to design more intelligent machines. In the next part of this series, I'll discuss a particular kind of neural network architecture that has allowed for the development of large language models, and highlight some of the issues that this raises in a quest toward artificial intelligence. Thanks very much for watching. Do like and subscribe, and I hope to see you soon.